The question here says find the lengths of all unknown sides. Find the lengths of all unknown sides. And we are given only one angle, which is 38, and we are given one side, which is AB, which is 10 meters. Now that AB, what is the relationship between this given side and the given angle? You realize that AB is adjacent to 38. So whatever we need to use here, we're going to be using only two ratios. We will be using the cos ratio. We should either use the cos ratio or the tan ratio. In the previous example, I used the tan ratio. In this case, I will use the cos ratio. If I use the cos ratio, note that I will have to solve for hypotenuse, because the relationship between cos simply gives you adjacent over hypotenuse. So I do have the angle, I do have adjacent. The only thing that I'm going to be missing is my hypotenuse. If I used tan, I was going to calculate the opposite, because I do have adjacent, I do have the angle, and tan is opposite. It is opposite all over adjacent of the angle. It will be equal to the tan of the angle. Tan of 38 will be opposite over adjacent. So we'll have to solve for opposite. In this example, I will be solving for the hypotenuse, because I'm going to be using, actually I use 10, it means it's the example where I use cos, sorry for that. I'm going to be solving for opposite, because I'm simply using 10. 10 of 38 will be opposite all over adjacent. I do have the adjacent, and I do have the adjacent, and my adjacent is 10 meters. All I'm going to do is just to substitute that 10 meters and solve for opposite, and my opposite will simply be equal to 10 of 38 multiplied by 10 meters, which will simply give me 7,8 meters, and my opposite will be 7,8 meters. Now I'm left with my hypotenuse. For me to solve for my hypotenuse, I'm simply going to be using the theorem of Pythagoras, which states that your hypotenuse will be equal to sum squared of the other side. So basically I'm going to take 7 squared plus 10 squared, and that will give me my radius squared, which is my hypotenuse. And in this case, obviously, r will simply be the square root of 100 plus 60,84, and my radius will simply be 12,68, which is simply my hypotenuse. Let us quickly do example 3. In example 3, I am given the hypotenuse. Hypotenuse is a side that is opposite 90 degrees. Now I am given the angle. Now in this case, I'm missing my adjacent. I'm also missing my opposite. The opposite side of 30, I'm also missing the opposite side of the adjacent side of 30. Now I only have two options here. It's either I use the sine ratio. If I use the sine ratio, I'll be finding AB, because sine is simply opposite over adjacent. Okay, so sine of 30 is equal to opposite all over, hypotenuse. I repeat, sine of 30 is equals to opposite, a side opposite 30 all over hypotenuse, which is 20. If I use cos, I will simply say adjacent, which is BC, over 20 will be equal to cos of 30. So cos of 30 is adjacent BC all over hypotenuse, which is 20. Now in this case, I simply let me just label them. In this case, I simply found my cos. Basically, I'm looking for the adjacent. This is what I'm looking for. So the relationship between adjacent and the given side will simply be cos. So it's adjacent all over hypotenuse will be cos of 30. Now for me to solve for BC here, I will simply multiply both sides by 20, and BC will simply be 17,3. All right. Now I'm simply missing my opposite. I'm just going to use the theorem of Pythagoras to find my opposite. I do have the hypotenuse. I do have have my opposite. The only thing I'm missing, I do have my adjacent. The only thing I'm missing is my opposite, all right? And when you solve for AB squared will simply be 100.71. Find the square root. AB will simply be 10. In this case, my AB is equal to 10. Example 3. In example 3, I am given a side adjacent to 50,7 is 4,3. So basically, I can only use 10, or I will simply use cos. So I can only use those two ratios. Those are the only ratios that have adjacent. It is 10 as well as cos. Let me see if this is the example where I used cos first. Yes, this is the example where I used cos first. So cos will just be adjacent all over my hypotenuse. So I will simply be finding my hypotenuse, all right? I just had to correct a minor mistake. This is what we are given here. We are given the hypotenuse, not the adjacent as I initially stated. We are given the hypotenuse, which is 6,74, and we need to either find our adjacent or opposite. Please note that since I'm given only the hypotenuse, I can only use the ratios that have hypotenuse, and that will be your sine, which is opposite all over hypotenuse, or I can simply use my cos, which is adjacent all over hypotenuse. In this case, I'm going to find my adjacent first. Now, since I'm going to find my adjacent first, I will simply use cos of 50,7. So adjacent to 50,7 is adjacent, but hypotenuse will simply be 50, it will be 6,74. Manipulate the formula for you to find the adjacent, and your adjacent will simply be 4.3. Once you have one side, you can use any of the ratios, but after finding one side, I prefer to use the theorem of Pythagoras. I do have my hypotenuse, I do have my adjacent. The only thing missing is my DC. My DC is simply my opposite. I'm just going to manipulate that theorem of Pythagoras to find DC, and DC will be 6.7. Let's move to the next one. The next one is actually a worksheet. This is your work for today. Please do all these activities and email them to me. And next we're going to be doing finding angles. Okay, that will be our next topic. So next topic is simply finding angles. Till next time.